Hello everyone. Let us see what is a policy based data structure, and this data structure comes in C++. So we'll see how to declare this data structure, basically declaration of the data structure. Secondly, what all lines, headers, namespaces are required for this data structure, right? So let me just write it. Namespaces, right? And thirdly, we'll see its important functions. There are two important functions of this data structure that makes it different from other data structures, right? And then we'll try to code it down. We'll code the data structure, then we'll see how it will work in Windows and Ubuntu. And after that, we'll try to submit a question on code forces using this data structure, right? And let's say we'll also do one more question, that will be inversion count, counting inversions using policy based data structure. It's just a 2-line code. Okay, so moving on to the declaration part, right? So here we are. These are the header files that I need to include in my CPP file, right? So the files are include kernel policy based data structure pbds and associative container.hpp. Okay. Again, the second header file, it contains the tree policy that will be used. Okay. Now this data structure is different because it contains a order statistics node update function, right? We'll know about this function later. Now the next part is, this is a namespace file and we'll include it after including the header files. So the namespace file is _gnu and _pbds. It stands for policy based data structure, right? Now we'll see the declaration of the container. Okay, so actually we don't have to code all this, the declaration and this and that. It's just for us to understand. Okay, and if you want to go much more deeper into this, so what you can do is you can try this link, and in this link you will get everything about the policy based data structure. Okay, but here I'll just give you an overview of data structure and how to use it in various questions. Okay, right? So guys, let's see the declaration of the container. So we all know that above a class we define a template, right? So I'll just explain you the template, and then we'll see how we'll write our own template. So guys, the first part of the template is a key type, right? So this key can be integer, it can be pair, right? It can be pair of string and integers, right? Anything. Look, what do you want it to store? What do you want that data structure to store? Do you want it to store integer or a pair or a string, right? The second map policy is that if you use a null type policy, that means you use a set, right? But if you use null map type policy, then you will use a map. Basically, again I am repeating the same thing. If you want to go in more detail, you can go for the website link that I provided to you. There's a lot of information available on that link. Okay, and I'll also explain you that how we'll code it down to use it. Okay, the third is the comparator, right? So how do we want it to compare the keys? Okay, whatever the key is, how do we want it to compare those keys? We want it to compare those keys by less int, like if a is less than b, then a comes before b in that set. Okay, otherwise there is one more, it is called less equal, right? So everyone has their advantages and disadvantages. Now there is a third type in the template. Here we have a tag, right? So this tag is an important part of a data set of this policy based data structure, right? So guys, there are different types of tags. The first is a arbitrary tag, that is that how do I want my container to function like. I want it to function like a red black tree. Well and good, I will write an arbitrary, right? This is a tag. Otherwise, if I want it to function like a split tree, I will just write split tree tag. Okay. Otherwise, I'll write an OV tree tag, that is an ordered vector tree tag. I hope you got this. There are different types of trees, and all these trees have their different functionalities. They split accordingly in the time. You can read about them, but it's not needed. Okay. But for your own curiosity, you can try it. Right. After this, we'll have we'll have a node update policy. This is the main part of the data structure, a node update policy, and an allocator type, right? So we'll see how we'll define this. Basically, I'll define the policy based data structure in this way. Okay. So what does this int means? It means a key. So here I have a key that is an integer type. Basically, the set that I have contains the key integer types. Okay, I can insert only integer types of data. I can change it to pair, I can change it to string, whatever you want. Right. Now I have a, as I already told you, I have a map policy. If the policy is null type, then this stores, this structure works like a set. Okay, that means no duplicates are allowed. And there are other policies, null map type policy, you can read about them, but this is the one that will be mostly used. Okay. Then I have a container, sorry, it's a comparison function. Okay, so this comparison function I have to provide it. There are various functions in the library, you can read them about. There's a less in function, less equal function, right, greater function. So you can you have to provide the comparison function to the above declaration, so that it knows how to compare two keys, right? And after this, as I already told you, we have a tag. There are different types of tag: arbitrary tag, split tag, right, ordered vector tag. And after that, we have pre-order statistics node update. This is the important part of the set. Okay, so I have defined this whole as new data set. Okay, so in the coming video, I'll just define this in my code, and then I'll show you the functionality of it. Right, moving forward, this is the final declaration that we'll use. Okay, and this is the link where you can read more about the data structure. But after watching 1-2 videos on it, you can easily understand it, how to use it. You don't have to go much deep into it, but it's your curiosity, right? Okay, so first of all, how do we set it in Ubuntu? So in Ubuntu, we all know that whenever we compile this policy based data structure, it doesn't ask for other uh, it doesn't require any other files, right? So in Ubuntu, we don't have any problem while compiling this data structure, right? But in Windows, is a quick explanation that I got in my laptop. So see, when you go in this file, wherever your compiler is being installed, go to this, and after this we'll reach a file name called hash standard resize policy, right? So actually that file has been wrongly named there. It has been named as hash standard resize policy imp.hpp 0000644, right? So you have to just erase this and save it, and then the policy based data structure will start working on your Windows PC, right? So let us see how we'll code this down, how we'll code the policy based data structure. Okay, so before this, I'll also explain you the two functions that make this data structure different, right? So guys, basically this policy based data structure, it works like a set. It has all the functionalities of a set. Okay, so why do we need it? But if it has all the functionalities of a set, this policy based data structure has two other functionalities. First functionality of the policy based data structure is it helps, let me write it, find by order. I'll also code it down. Okay, so the find by order functionality, it returns, let me just pass a variable k. Okay, so it returns the iterator to the kth largest element. Okay, basically I have to start from 0. Okay, so I'll explain, don't worry. Start from, like, zeroth largest is actually the first largest. Okay, right. And the second new functionality is order of key. So the functionality order of key, it returns the number of elements in the set which are strictly less than our value. Okay, so in this also I'll pass a value, that is, let's say k, and we'll write k. Okay, so these are the two important functions. These two important functions are not supported by set, and these functions work in log n time, right? So when I can easily find out key which is the kth largest element in a set in log n time, and I can easily find out that how many elements are smaller than a current element in a set, so it can solve my various questions, right? I'll show you how, and I'll also give you examples of various questions. So generally, to find this, the kth largest element in a set, we try to use binary search over it, right? So instead of writing it again and again, what we do is we'll just use policy-based data structure, right? Using binary search takes log n time, right? But this will only work in log n time. Okay, so these are the two important functions of policy-based data structure. I will code it down. Okay, and now let us move forward, right? Let's have a quick example of these two. Okay, let's say, okay, find by order and order of key. Let's say I have a set, I have defined a policy based data structure. Let me name it new data set, let's say S. Okay. So what I did is I'll insert something into S. Okay, let's say this is a set and it contains some values. Let me just insert some values: 1, 3, 4, 10 and 15. Okay, so it will keep everything in order. Now let's try to use this function find by order k. Okay, so guys, if I try to use the function find by order, right, and I try to pass 3 into it. So what does this function do? This function returns the iterator to the kth largest element, right? Basically, if I index this array with 0, then this function will return me an iterator that is pointing to 10. Okay, so what does this mean? That basically all the elements that I have inserted in the set, they are stored in increasing order, and I can easily find out which is on which index, which I means that which index contains an element, right? So basically, I hope you got this. In short, it means here I am passing an index, and it is telling me it is written me an iterator that is pointing to this index. I can easily use this value. At third index I have value 10, right? Okay, now let us use this second function called find order of key. Okay, order of, so this function order of key, this function tells me that what is an order of the key in the current set, like how many elements are strictly smaller than current element. Basically, just realize it, guys. Okay, basically if I pass 10 to it, then it will return me 3. What does this mean? That the order of 10 in the current set is 3. That means there are 3 elements that are less than 10, right? I can say it in another way, that it actually returns me an index of that element, right? Because 1 has an index 0, so there are 0 elements that are less than 1. 3 has an index 1, that means there is only one element that is less than 3. 4 has an index 2, that means 4 has two elements that are strictly less than 4. I hope you got this. Okay, so basically these are like vice versa things. So we can just pass on an index and find the value, and we can pass the value and find the index, right? Okay, now guys, there is another question, that if the value is not in the set, then what will it return, right? Let's say I'm trying to find order of key 11. Okay, so guys, what will the order of key 11? Strictly going with our definition, it returns the number of elements in the set which are strictly less than k, right? So it will point to 15, right? Basically 4, it will return me 4, right? Why? Because we have 4 elements that are smaller than 11. Okay, so guys, you can generalize it in a second way, that let me write those values: 1, 3, 4, 10, 15, right? Basically it returns me a, let's say, a lower bound. Okay, so see this: if I try to pass on 11 and 11 was not in my set, so it tells me ki if 11, if I include 11 in my set, then it will be at which index, right? If I include 11 in my set, then 11 will come on the index 4, right? Otherwise, if the number that I am passing on, let's say 15, it was already in the set, then it will directly return me the index at which it is in the set. Otherwise, if the element is not in the set, then if I insert that element in the set, then at which index will that element come, right? So you can try to understand it an other way, this way, or the definition way, or another way that you want to make by yourself. But I hope you got the use of these two functions, find by order and order of key. Okay, so in the next video we'll code it out and also run on some examples of the given functions.